Hi class, I'm your virtual science helper, Mr. Frizzle, and today we're going to learn about friction and how it actually affects motion. So, the way we're going to test this is I've got my friend here. It's Fred the red chicken. He's got himself a sled here that I made out of a milk carton, some aluminum foil, some masking tape. And what we're going to do is we're going to send Fred down our ramp here. We're going to send Fred down the ramp and see how different surfaces affect the friction and if Fred goes faster or slower. Here's test number 1, where we just have a regular smooth surface. Here we go, 3, 2, 1. All right, so Fred went all the way down to the bottom, and there was a bit of friction. You can hear it rubbing together, but Fred was able to make it all the way down to the bottom. So, what if I were to take some of this masking tape here and make a few racing stripes for Fred? You think he'll go faster, or you think that the masking tape will actually slow him down? Let's just see here. Got 1. So, we've got 7 racing stripes here for Fred. Let's see if Fred the red chicken will go faster, or he'll make it to the bottom, or maybe the masking tape will stop him. Make sure it's all flat here. Alrighty, test number 2, smooth surface, but with masking tape. He seemed to have made it all the way down to the bottom still, but you could see as he kind of rolled down, his sled got a little bumpy. But he still made it down to the bottom, so let's see. Let's get a little bit more of a rougher surface. I've got some carpet here. Let's see if we slide Fred down this carpet. Let's see if he'll go faster or if he'll even make it to the bottom. Let's see what happens. All right, test number 3, carpet. Well, he seemed to make it, he made it almost to the bottom there, guys, but he moved a lot slower because of this carpet. Let's do that one more time. See if it'll go slower or faster. Oh. This time he made it all the way to the bottom, but it was much slower, guys. All right, I've got one more surface. Get rid of this carpet here. Something that's a bit more rough. I've got some sandpaper here. Now this stuff is really rough. We're gonna have to tape this on. All right, so test number 4 is with sandpaper. Are you ready, Fred? I'm ready. Let's see. Test number 4, sandpaper. 3, 2, 1, go. Fred. 3, 2, 1, go. Well, I guess because this surface is so rough, guys, the sled cannot even slide down, not a bit. Even when I push it, it seems to be really tough to even push, right? Even if I give him a little push, Fred stays in the same spot. So what can we learn from this? This all goes together with Newton's laws of motion, guys, and has to do with friction. You notice that when we had the smooth surface, that there was less friction. And even when we added the masking tape, there was a bit more friction, but Fred was able to make it all the way down to the bottom of the ramp. Once we added the carpet, Fred was able to slide all the way down to the ramp, but it was much slower. But then, once we added our sandpaper, Fred didn't move at all because there's so much friction between Fred's sled and this sandpaper that he will not move even if I push him, which is amazing, guys. Now, Newton's laws of motion are a fantastic thing, guys, and we'll get more into them in a further lesson. But until then, I'm your virtual science helper, Mr. Frizzle. Have a great day, guys. Bye.